here, and great to have so many people joining. We're going to jump right in since we have about an hour. As Devin said, the workshop materials are there at the Go link that's on the page. We're going to keep on posting those periodically as people join. We'll post those in the chat just to make sure that all the resources, that everybody does have the resources. All of those are completely open. They'll continue to be available for quite a while. I won't ever take them down, so they'll be there. I'm going to go ahead and take over the screen sharing. And what you're going to see on my screen now is the workshop repository. And so if you went to that Go link, you'll be here on this GitHub page. What we're going to be doing is actually writing some code together today. So we have an hour. We could do a sort of a dive into Python and start trying to learn the syntax. So how do we actually put the language constructs together? We could be looking at the semantics, how these things work. We could look at different libraries. But what I really wanted to do is try to take everybody through and have an actual experience of writing code together. So our goal today is to learn a bit about Python and what you can do with it through writing code together to achieve a common task, something I do all the time with Python, which is just analyzing tabular data. So tabular data is things like spreadsheets, Excel files, CSV files. We're not going to be trying to develop mastery today. We're not even going to try to get to a solid introduction to Python syntax and patterns. We are going to try to have a good hands-on experience doing something practical while learning about the language. And then after the workshop, I have my calendar blocked for a bit. So I'm going to hang around for a while. If you have questions after 3 o'clock and you want to hang around and ask, please feel free to. So what we are going to analyze today, our data, is data about public libraries in North Carolina that's coming from the State Library of North Carolina. I have put a copy here on the GitHub page, but there's a link here to the original data. So getting into how we're actually going to write and run our code. We're going to be working in an online environment so that we're not worried about setting up Python on everybody's computers. That can take a little bit of time. We want to jump in and just start writing Python together. And you have a couple of options here. The idea is that you'll write Python along with me as I'm writing Python on the screen. But if you aren't there yet, you're just not feeling it today, and you just want to be able to run the code, there's a second version of the workshop, and you can actually just run the code that I've already written. And if you just want to watch and listen in and see what's going on, that's also completely cool. So if you do want to run the code or write the code along with me from scratch, there's a link here. So this first open in Colab button where it says clean notebook to code along. If you want to right click on that and open that in a new tab, what you're going to see then is a completely blank notebook here. And what you'll do here is hit this button that's sort of at the top middle, which is copy to drive. You do have to have a Google account, but what this is going to do is it's going to create a copy of this notebook, which is where we're going to be writing and running our Python code, and associate it with your own Google account. If you want to just go ahead and open up the rest of the materials, which I certainly recommend doing, just as a reference, this second link here that says fully written workshop materials, you're also going to want to right click on that, open that in a new tab. If you want to run that code, you're going to do that exact same thing, which is hit the copy to drive button. If you just want to be able to see it, you're not too worried about running it, then it's just there. And again, all that's going to stay up online. It'll be there for you. The last thing that I do have on this page are a set of resources for learning Python. Like I said, we're not going to be doing a deep dive into language. We're here more for a hands-on experience and to learn what we can along the way. But there's a lot of great resources online for learning Python, whether you're coming at it from a data science perspective or scripting perspective. We'll talk a little bit about that. But there's a number of things that are here that are pretty much all of this is free. A lot of it's great resources. You can definitely follow up with that. So with that, let's go ahead and jump into code. If you do look at this filled version, NC Live Python filled, you'll notice that this is sort of written a little bit conversationally. I have my own notes up to the side, so if you see me looking to the left, I'm also looking at it there. But this has the sort of explanations for as we go. And if you're ever wondering or getting lost, you can always look here. So if you are going to live code with me and you're not exactly sure, you don't want to necessarily focus on my screen. If you're like me and you're just on a small laptop, then you might want to have that open in the tab so that you can look at that rather than needing to look at my screen. But where we are going to go first is right into our code. So this is your NC Live Python clean.ipynb file. It's the one where you had already hit that copy to drive. And Devin, if you can share the Go link with people as they come in, or just put it in chat again, and maybe talk people through those initial steps. So the first question that we might ask is, why Python? Why would we want to work with Python as a programming language? And there's a lot of different reasons. One is that it's multi-use. It is a general purpose programming language. You can use it to write simple scripts, to automate tasks, to do things that you regularly do with your computer often. You can write really complex code for machine learning and do a lot of data science work, a huge amount of the work that people in the big industry, companies like Facebook, Google, Amazon, they're writing a ton of Python code for machine learning. You can build full-scale web applications in it. And depending on what type of library you're at and what their technical stack is, your library might have applications running in Python. The biggest reason that we see people working with it here at NC State and in the institutions I've worked at previously is really data science. A lot of people want to learn Python right now because they want to analyze data, whether that's structured data, numerical data, or whether it's text data, or whether it's something like MARC records. Maybe you have a lot of XML and you need to be able to process and work with that. Python is great for all of these different things. So I do want you to just take a second if you want to, you don't have to. If you have one reason that you really wanted to learn Python or a reason that you were interested in it today, feel free to go ahead and stick that in chat. And maybe it's good for folks to sort of see and read reasons why people might be interested in Python. We are going to be working online today. We're working what's called a Jupyter Notebook. Very specifically, we're working on the Google Collaboratory or Google Colab platform, which is just a Google hosted version of Jupyter Notebooks. What Jupyter Notebooks do is they allow you to write code sort of one line at a time, run that code and get immediate feedback. They have become really, really popular in the scientific world, in the data science world, because you're able to weave together Markdown, so plain text, which will allow you to sort of give explanations along with your code, along with all the visualizations with different views of your data. So you're able to weave together all the different parts of any type of analysis and prototyping code, and you can generate reports out of these. And so they're really useful. So we're going to work with Jupyter Notebooks in Colab today. And what that's going to allow us to do is to not really worry about setting up Python on your computer. Some of the resources that I shared on that GitHub page certainly do allow you to do that though. So if you are going to be coding along with me, we are going to go ahead and start that now. But if you're just going to be sort of following along and running the code that's there, remember it's here in this NC Live Python field. And that was the second open in Colab button at that Go link. And you can just sort of click the copy to drive so you have your own copy. And you'll be able to just run the code as you go. I'm going to start from scratch over here. So one thing that I do very often in Python is actually work with tabular data. So again, things like CSV files, Excel files, and do sort of basic analysis, things that you might do in Excel or that you might do in Numbers or in OpenOffice or LibreOffice. So I do a lot of data analysis, and I weave data analysis into a lot of the work that I do. A lot of my own focus is on computational text analysis and machine learning, but I'm almost always working with CSV files one way or another. So I thought what we would do today is actually take some of this Excel data from the State Library of North Carolina and just do a little bit of analysis and see where we get to. So I'm going to go ahead and start writing code. Again, you can write code along with me or just run the code as you want to. So there's an empty cell here. The cells on this page are these little grayed out boxes. You're going to be clicking into that first one. And the first thing that we need to do in Python typically is import the libraries that we want to use. So I'm going to type import. Let me make this text a little bit bigger there for you. If you're not able to read the text on my screen, again, you can look at the version of it that's filled as a reference so that you know what to type. But you can also let me know in chat if I need to bump up the font size. So we're going to first import a library, and it's going to be import space pandas as PD. So this is the first thing that we need to put in here. And the reason that we're doing that, Python comes with a standard library which has all the basic functionality, but we might want to be able to work with some of the different libraries that have been created that allow you to do really domain specific work. or libraries that simply make it easier to do some tasks. Pandas is a library, so it's additional functionality that is one of the most commonly used Python libraries. And it's the main library that people use to import data, to do basic data manipulation, to clean a lot of their data, to do some basic graphing. It's really a fantastic library, and you'll see it quite a bit. When we import that library, we're taking it, we're getting it from our environment, and we're importing all the functionality into our particular Python session so that our Python process knows about that functionality. We're going to do something a little specific here, which is to import it with a short name, PD, and you'll see how that makes a difference in a minute. This is something that you sometimes, that you see often with Pandas. It's almost always imported as PD. All right, so the way that you run code when you're in a Jupyter Notebook and Google Colab, one, you can sort of hit this big play button that's just to the side. And if you hover over it, it does say run cell. It should also give you the keyboard shortcuts. And the first time that you run it is going to go through the connecting process. Just let that happen. It'll work through. The other way that you can run these, you can always hit Shift Enter. And I think that on Mac Command Enter also works quite well. So the next line of code, I'm actually going to have you copy and paste just for a minute. It's a little bit longer, and we don't want to, I'm not going to explain this one as much. So the second line here, pd.setOption. So if you go back over to the filled notebook and just copy that line, we are going to copy that one into a cell and run it. What this is going to do, I'm not going to explain this one too much, just in the interest of time. This allows us to bypass scientific notation, because otherwise Pandas likes to give you a lot of long decimal numbers with scientific notation, and that makes it a little bit harder to read sometimes. So this is just saying round everything to 2 decimal spots when you're displaying it. So the next thing that we need to do is we need to actually import our data and save it to a variable somewhere. So what we're going to do first, my preferred way of doing this, is to set a new variable. A variable is a name under which we're storing some value. And then we can use that variable name repeatedly in order to refer to that value again and again. So I'm going to say data space equal space. So in Python, when we assign variables, when we're saying save this value under this particular name, we just use an equal sign. We use one single equal sign. So we'll say data equal. And what I want to do is actually put in a URL, so a web address here. In Python, that's a string, so that's text. And so we do that with double quotation marks. Could use single quotation marks, but I think the best practice is using double quotation marks so that you're able to handle apostrophes and such. And then we do have, again, a long URL link. This is the last thing I'm going to ask you to just copy over from that filled notebook. We go back over there and see this URL. I want you to just copy that one. And we'll copy that inside of the quotation marks. It's a little bit wider. So what you should have in this particular cell is data space equal space double quotations, and inside the double quotations is the URL where our data lives. So this is the URL that's up on GitHub. And we're going to go ahead and run that. So after we type each thing in each cell, we're going to go ahead and run that cell. And you might notice that we now are able to see the order that we run our cells above. So in the very left-hand side of each of the boxes or each cell, you can see a square bracket that has 2, 3, few might be 1, 2. That's the order in which we run things. Right. So underneath this, we're going to create a new code cell. If you sort of hover between the cells, it'll give you an option to create either a code or a text cell. We're going to create another code cell. And what we want to do now is actually read in the data into our Python session. So we want to store that under a new variable. I'm going to call mine df for data frame. A data frame in Pandas and in Python is a tabular data structure, which gives you a good bit of other extra functionality around it. So I'll say df space equal space. And then here's where, if we remember, we imported Pandas as PD, we'll do PD. So we're going to call the functionality that comes from the Pandas library. And then we need read underscore Excel. So Pandas as a data manipulation library comes with a bunch of different functions or methods to allow you to read in different data types. Since we know, because we look at the end of our URL, that this is an XLSX file, it is an Excel file, we're going to use the read Excel function. At the end of this function, we're going to type our parentheses. What the parentheses do in Python is they just call our that function, so we're actually running it. And within that, we want to put our data so that it knows that we're getting our data. And that's what we're passing into this data frame function to, or this data function to read it. And we could just stop here and run this code. And if we run it, let's see what we get. It runs it successfully. One thing that's nice about Python, if the code is not able to run, it is going to give you an error. You'll notice if we took a line off there or took a parentheses, it might give us a syntax error. So we're getting sort of immediate feedback. This is one of the nice things about working with Jupyter. I'm going to put that parentheses back. And then in the next cell, if we wanted to actually print out and see whatever is there within our variable, what value do we have stored there? We could put df, which is just the name of our variable, and just put that in the cell and run it by itself. And you can see that what we get back is quite a bit of data. So what this is that spreadsheet data. But one thing that you might know is that spreadsheets often have multiple sheets. If I'm interested in actually just in one sheet, I could specify that a few different ways. What I'm going to do is go in and edit this file. That's the df equal pd.read_Excel. I've got data. What data is here is it's called a parameter. Parameters are options that we pass into functions when we're calling them. All of this I know can seem like really technical language and information. So if you haven't come across this, that's completely okay. Not going to be able to explain all of it today, but a lot of the resources that I provided you are great at digging into it. For now, keep coming with me. Go ahead and run code, write code, and then we'll sort of work through explanations as we go. What I'm going to do is pass another parameter in here, which is called sheet_name. And I want to tell it the actual sheet that I want to use. In this case, I know that the one I want to work with today is one called Table 7 Collections. I know this just because I opened up that Excel file in Excel on my computer. And so I'm going to type out within the parentheses or within the quotation marks, table period 7 period collections. And we could go ahead and just rerun this. So we could hit that little play button again. And then where we have df below, we could hit that again. And we'll actually get different information here. And you can see sort of in that 0 row, we have table 7 there in the unnamed for column. We're going to work on addressing all those as we go here too. So what we've done here is we have created a variable df. We have read an Excel data sheet directly from the internet by way of a URL into our Python session. This could have been a local file. Also, you can pass in a local file name, a path to a file on your computer in the future. That works just fine. And we've specified a particular sheet. So we've passed in 2 different parameters, our URL where our data was and a sheet name. I want to add one more because when I look at the data here, and part of what's great about working with programming languages in Python, we can do this really iteratively. I can start with just that parameter data, pull in some things, realize, hey, I actually want a different sheet, add that parameter in. Then I can look at this and go, hey, there's a bunch of sort of NaN values here. Those are not a number values. This is what Pandas is doing to fill in empty data. If we opened up this entire Excel sheet in Excel, we would see just empty cells. And we can see that we have what looks like title information up above in top rows of our spreadsheet instead of the actual column names. And what I really want is to get the information that's here on row 3 for me, things like FSCS key, legal name, the library type. I know that from looking at these, that these are the actual column headers. These are the columns where my data lives. So I want to actually tell Pandas here that I want to disregard these few columns. And I want to really start with this row here, the 3rd row, or row 3 as the header row. So I'm going to go back up to this line where I read in my data, and I'm going to add a new parameter. So we have this data, comma, sheet name equal table 7 collections. We're going to add a new comma, which says we're going to pass in another parameter. And this time we're actually going to put header. So I'm going to be able to specify the header row equal to 4. And if we go ahead and rerun that code, again, you can hit the play button, you can hit Shift Enter, and then rerun the cell where we just have DF again. And look at the top, we can see that we now actually have our correct column headers. So we're able to see in bold here, the legal name, library type, cataloged adult books, cataloged juvenile books, book volumes, all that's now there within our, as our column headers. So that's great. So we're going to say from here on out that we've got our data successfully imported. Right, Eric mentioned in the chat, this is a great thing to notice. Python, when you start counting in Python, you always start counting at 0. And so that's why this first row is 0, and then 1, then 2, and 3. So the fourth row, when we're specifying here header equal 4, we're saying the fourth row, but the index of that, which is the number of item where that is actually 3. Again, you just start counting as 0. Different programming languages do this in a different way. The other language I do a fair bit in is R, and in R you start counting at 1. But Python, we count at 0. There's a lot of other languages you count that, and you just get used to it. The more you do it, the more it makes sense, and you stop thinking about it as much. When you start working in a bunch of languages, then you start to get yourself confused, though. But that's a great thing to notice here. All right, so we've got our data in here. When we do this DF and we get the printed out version of the whole data frame, again, a data frame is just a construct. It's a data structure that lets us store tabular data and then do things with it. We can see that it abbreviates the data, it sort of slices it so it's not too big on our screen. We can see that we have 89 rows and we have 17 columns. That means we have 89 observations. We have 89 different public libraries that are noted here, and we have data in 17 columns. If we just wanted to look at the top of this, then we could use a different function, or in this case, it's a method. So we'll call df. So if you don't already have it, you can create a new cell. Again, if you sort of highlight right between the cells in Google Colab, it gives you either a plus code or a plus text. There's also up here at the top, the buttons that say plus code or plus text. You can hit those as well. We're going to have df. We'll put a period in there, and the period allows us to say that we want to add a new function. We want to call a function off of that variable. So we have our variable dot. We're going to call a function called head. What head does, again, since we're calling it, we want to actually run that function. We do need to put the parentheses on it. What that df.head does is it by default is going to return just the first 5 rows. So this is something, if you start to look at documentation for Pandas or just read other people's code, you'll see people do df head very regularly in their data analysis code just to get a peek at what does the data look like. And this might be the way that you start to explore that a bit. Maybe you want to see more than just the first 5 rows. In the same way that when we did that read Excel function, we passed in parameters. df.head also has parameters also, or that .head function. One of the main ones is just going to be in. And we can do in equal, and then the number of rows that you want to see. So by default, it's 5, but let's say I want to see the first 10 rows. We could put in equal 10, and then go ahead and run that code. So again, you can hit that play button, and you'll see that we're now able to look at 10 rows. So this can be a really useful thing. It might be something that we want to go ahead and look at. One thing that we might start noticing, though, is about our data. We have the correct column names, mostly, but right here on the front, we have this unnamed :0 column, and all of the values in there have NaN, which again is not a number. It's what Pandas is using to fill in empty data. And we might ask, okay, I can see then the first 10 rows. I've definitely got this empty data, something I might want to deal with, but is that there at the end of my data file, right? Is it really empty all the way down? So one thing I might do is run another function. In the same way that we have the head function to look at the top rows, we have a tail function to look at the bottom. So I could do df.tail. And then again, the parentheses, which say to Python, I want you to go ahead and run this function, and we can run that cell. If we do that, then we get that unnamed column. And we're able to see actually some other interesting data here at the bottom. We still have the not a number there in the unnamed But then we have a bunch of what looks like summary data. I don't know any library types that are average, 25th percentile, median. There's no legal name here. If we keep sort of scrolling across, then we see what look like summary statistics. So if I looked at this, I might go, wait, that also seems like information that doesn't really belong in my data set. It's going to be a little bit hard to analyze that. So let's drop that out also. If we looked at this and you saw there's the last 5 rows, but is it also there in the rows previous to that? How many rows do we need to drop from the end of our data? The same way that we passed in the parameter into our head function, we can do the exact same with our tail function. So we can do this df.tail. Inside of our parentheses, we pass in a parameter. So we'll say n equals 10. So let's look at the last 10 rows and just go ahead and hit enter on that. And if we then start to look at our data, we can see that we have up through row 81, we have the actual libraries that we're interested in, that we're trying to look at. And then we have a couple of empty rows and then the summary statistics. Having the summary statistics here is great if this is a report. And in fact, this is a report. You want someone to visually be able to see this. But for us as people analyzing data, we want the data in our data frame to just be the data we want to analyze. We don't want to have other information there in a way that makes our data malstructured. In the R world, this is called tidy data. We want to have one row for every observation, one column for every variable, and we don't want to have extra information in our data. So the next thing that we want to do here today is start to clean this data. So the first thing that we want to do is drop these last rows that don't have any information. So there's a function in Pandas called drop. So we're going to start with our variable name, which is df. df is, again, that variable where we have all this data stored. We'll do df.drop. So that's our drop function. We have to use our parentheses because we want to call that function. And then we want to start putting in parameters. You may have noticed that you start getting pop-ups here in Google Colab. These are very handy pop-ups. They're giving you information about what parameters can go into a function and how to use that function. So in this case, we would be able to look and sort of scroll through and we can see the parameters that go in. Way down below, we're actually able to see examples of how to use that function. This is a really handy feature that Jupyter Notebooks generally give you, in which Google has done a really nice job in implementing Google Colab. So we're going to say df.drop, and then what do we want to actually drop? So one way to do this is to specify the indices, so the row numbers of the columns we want to drop. And then one way to get that is actually just to, as a parameter called df.tail, so the exact same function that we've been using to look at the last rows. We still want to call it, so we still have to have our parentheses. And we want to say how many rows are we actually wanting to drop. I want to drop those last 7 rows. And what df.tail does with the 7 in there, you can do this as n equals 7 or just put in 7. That will return the last 7 rows. So I'll use that and then call .index. But I'm not going to put parentheses after it, because in this case, what we're doing is we're getting a property instead of a method off of these rows. And so what .index will do is actually just get this 82, 83, 84, 85, 86, 87, 88. It'll just get these indices off of that. So after index, we're going to put a comma because we want to pass another parameter. And our parameters in Python within a function are separated by commas. And we'll go ahead and put in place equal to true. And true here has a capital T. So in place means let's modify the value that we have stored in a variable directly. And then true is, in this case, a reserved word. It's a Boolean. Booleans are either true or false. And the capital T is what tells Python that this is a reserved word. And so we can see that it turned blue. So Google Colab is giving us what's called syntax highlighting. So it's highlighting the different parts of our Python statements in order to give us more information as people writing code. So looking back to this whole thing, we have our variable df, which is our data. We're going to call the drop function on it. What we want to drop is the last 7 rows, which we're getting back by way of df.tail parentheses 7. We're going to specifically get just the indices off of that. That's what the df.drop function is expecting, is indices. We want to do it in place. We want to modify the data where we have it. And so we could go ahead and run that data or run that code cell. If we want to make sure that it worked, we should, if we run df.tail again, so df.tail with the parentheses again, then we should be able to look at the end of our data. And if it worked, then all of the summary statistics that were at the end will no longer be there. When I look at the data after running that df period tail parens, then I can see that the last row is actually good data. It's for Wilson County Public Library. All right, so we've done one step in our data cleaning. This is great, but I also know that I still have this column right at the beginning, the unnamed 0, that I want to go ahead and take care of. So I might ask, all right, how can I approach that as a problem? How am I able to remove this? So one thing we know, we can drop column or we can drop rows by way of that drop function. Maybe we can also drop columns by way of that drop function. But let's make sure that we have the right column names. So in the same way that different types of data objects in Python, things like data frames have particular functions defined on them. It's functionality that's been built into it. There are also properties, which are not things that we can run, but information about that data object that we can get back. And so we'll do df. So again, that's where our data is stored. And I'll do .columns. And we'll go ahead and run that cell. And what that just gives us back is a list of the columns that we have within our data set. So if you take a minute and just start reading over those, does anything look a little bit strange to you in the column names other than unnamed 0? And if you see something strange in there, feel free to toss that into the chat. I'll give you just a second to look over those. It's a little bit of I'm looking for something specific, which is always a little bit unfair to ask. All right. Sanjit, hopefully I'm getting the pronunciation right, but if I'm not, I apologize. You're exactly right. So what was said in chat was that, are there extra spaces in some of the column names? That is exactly right. So if we look here at cataloged adult books, we're able to see a space there in the front. We get the same thing with cataloged young adult books, cataloged juvenile books, book volumes, but the space isn't there in all of our column names. This is something which is really interesting. I would generally say that you want to eliminate these when you're publishing data. I don't know if this is an error that's within the data, but it's the type of thing that if we're writing code to explore our data can be really impactful, and we're going to have to deal with that as we go. You could rename all of your columns or rename the columns to remove that space, or just include the spaces, which is what we'll do in a minute. What we want to do first, though, we know that we want to drop this unnamed 0 column. So I'm going to highlight all of the name of that column, so what's within the single quotation marks, and go ahead and copy that. And in our next line of code, in our next cell, what we want to do is to use that same drop function and then just get rid of that column. So we'll do df, that's our data frame, .drop, parentheses, so that we can pass in our parameters to it. And the first parameter we're going to have is columns equal. So columns is the parameter name, and then the value is going to be a list. So a list in Python is a set of items together, separated by commas. Our list is only going to have one item in it, which is going to be a string, which is the column name. So I have df period drop, the parentheses, so we're calling a function. I'm passing in the parameter named columns equal, and then it's equal to a list, and a list designated by the square brackets. And then in our quotation marks, we have unnamed : space 0, which is exactly as we copied it up from above. And then after that closing square bracket, I do need to put, again, in place equal true as a second parameter to this drop function, so that we modify the data exactly as we have it. And then one other little trick that we can show you, we've been just writing cells where we only have one line of code at a time. You can put many lines of code in a cell. The general way that we're thinking about cells is pull together the code that makes sense to have together. What I'm going to do now is I'm running this operation to eliminate a column to do a data cleaning step. And I want to make sure that that step actually worked. So I might call df df.head with the parentheses again and run that cell. So I had a question, can I repeat what the in place equal true is for? Absolutely. So a lot of these functions like drop, if we are running them without that in place equal true, what they return is a copy of the data that's been modified. So if we did that, we would need to assign that to a new variable. That's generally what I do like to do, or it's what I sometimes do, is to try to keep multiple copies of the data. If you're working with large data, that can be a problem sort of as you clean it and you have many copies in memory of it. But sometimes if you know exactly how things are going to work, it's great to just modify the value in place. So when we have this in place equal true, what it's saying is go ahead and make the change, which is running this drop function, and then take what we get back from that and assign that value to the df variable. So make the modification directly to the data that we have stored in memory, rather than giving us back a copy of that data with the modification and leaving the original untouched. So if we ran this cell that had both our df.drop and our df.head, then we can see that here at the front, we have gotten rid of that column of empty data that we wanted to get rid of. So that's fantastic. So at this point, I'm just going to go ahead and say our data is clean. We could go ahead and remove these spaces from the column names. We're not going to worry about it for the moment. What we do have, though, is nice data where we have one row for every observation, which every observation here is a public library. And then all of our columns are the actual data that we're interested in. So we're going to take a look and see what we could start to do with some of this. I haven't looked to see if my own public library. I'm originally from Cleveland County, North Carolina. Haven't checked to see whether that's in the data set, but maybe we'll look at that later. So what types of things could we do with this? Maybe the first thing we want to do is figure out how many of different different types of libraries we have here. So we have this column here called library type. And maybe we want to know how many of them are county libraries, how many regional libraries do we have in our data set? So there's a pretty straightforward way to do that with Pandas. We can isolate individual columns and then call different functions on those. So that's what we'll do now. So I'm going to type df. So again, that's our variable here that's storing all this data. I'm going to do square brackets, which allow me to get to individual columns. And then we want to put the column name within the quotation marks here. So you can see if you do look at my screen, or if on your own screen, what you've done is just df and square brackets. Google Colab has popped up a bunch of the column names. So this is what on some platforms you'll see called IntelliSense. It's giving you automatic completions to try to help you out and make coding a bit easier. I think this is a really great thing. It makes it, again, just a little bit easier to get into coding when the platform you're using actually helps you write your code. So I could just scroll down here and get to library type. You could also just type it in directly and be completely fine. So I have this df, square brackets, then within quotation marks, library type. And then after that closing square bracket, I'll put a period, and I want to call a function on this, which is value underscore counts. And again, we run parentheses in order to call that function. And we'll go ahead and run that. And what we can see is that we have, within this data set, we have 58 libraries that are county libraries, 12 that are municipal, 12 that are regional. We do get a little bit of extra name, like the column here is library type, and the data type, it's an integer data. It's a 64-bit integer. So that's the amount of memory storage there, or the size of the integer that's pre-allocated. What do you think is going to happen if we try to call this value counts on a purely numeric value or a numeric column? So let's say, what if we had this cataloged adult books? What do you think would happen if we call value counts on that? If you're not sure, go ahead and try it out. So if we do our df, our square brackets, and we could, again, we know that we have a little bit of an issue because we have some spaces which at the beginning of our column names. Let's go ahead and click on cataloged adult books. Again, you could type this out. If you typed it out, make sure you have the space. I figured that out because I tried it without the space when I was first working on this, and then it errored out on me. So then I went and looked at the columns, part of that iterative process. So we have df, square brackets for picking out an individual column. At the end of this, we'll call value counts, .value underscore counts again. And what it does is it actually, every single individual discrete value that's within our data, it counts the number of times that that appears. That's what value counts is doing. So when we have categorical data, like library type, it's either a county or it's municipal or it's regional. Anything where we have string data, limited number of values. If you've done qualitative analysis, these are sometimes called levels of a factor. It counts each of those. But when we run it on numeric data, it's trying to count each of those as a particular single value, and it's going to count the number of times that appears. And most of these, it does it as one time. But Pandas does have some really great methods, just like value counts, built in that allow us to get a sense of what's happening with our numeric data. So let's go ahead and try a different function. We're going to have the exact same line start of this, which is the df cataloged adult books. And in our new cell, instead of value counts, we're going to run a function called describe. So we have df cataloged adult books with that little space in it, .describe, quotation marks. And when you run that cell, we get information, sort of descriptive statistics that are about numeric data specifically. So we can see that the number of items is 82 items. We can see the mean or the average of that. We get standard deviation. We have the minimum value. So at least one of these libraries has 5,257 cataloged adult books. That's the lowest value that we see in that column. The max one actually has 838,574 cataloged adult books. They have a huge variation here, right? We have some libraries with a very, very small cataloged adult book collection. We have other libraries with a really large cataloged adult book collection. So there's a great question in chat. Does describe differentiate between different kinds of data? Since these are all numeric, count, mean, standard makes sense, standard deviation. Would it treat textual data differently? I would try it out. So if we wanted to look at one where we have textual data, we could do the df. And again, we have our square brackets. And if we know that library type, right? Library type was textual data. And we went over and did period describe, and then called that function. So what that gives us is, it tells us how many items there are. So the number of rows in that column, 82, tells us there are 3 unique values. The most frequent of those, the top most appearing value is county, and it appears 58 times. So one thing that I have a little section at the end of this workshop on why I think it's cool to do this in Python. One thing that I love about working in Python and other programming languages is experimentation. I firmly believe, like, if you have a question about does something work, what will calling this function on this thing do, especially if you're in a sort of a sandbox environment like this where you're not going to mess things up. We're not modifying that original Excel file. We loaded it into Python. We're going to mess around with it, but we're not changing it at all. That gives you a lot of room and space to experiment and to explore for yourself. The best way to learn to code, really the only way to learn to code, is to code. It's to write code and to write code again and again and to do it in ways that matter to you. And I think the more that you experiment, the more that you're able to answer your own questions, the more fun it is, the more exciting it is, the more that you learn. So awesome thing to do there. Great way to ask, great way to discover, great way to learn. All right. So we did see here that describe as a function or as a method does give us back different information when we're using it on different on columns with different data types. So that was really cool to see. And we're able to get some really good information, things like the count, the mean, the standard deviation, the quartile breakdown, all that sort of stuff. What if we wanted to see whether we could actually run this on the entire data frame? So this is another question. Maybe you looked at this describe function and go, all right, we ran it on a column, but could we just run it on everything? Let's give it a go. So if we did df dot describe and then the parentheses, so we're calling the describe function or method on the entire data set. And here's what's really cool. We're getting back that same numeric information on all of the numeric columns. right? So for everything except for library type, and then the that initial code thing. So what it's saying is it's looking this describe function, whoever, right, the people who authored Pandas, a lot of different people have contributed to it. They decide if someone is calling the describe function, they want to know what most of the columns are like. Since most of these columns are quantitative, they're numeric, then it's going to it's going to look at all the ones that are numeric and give us back this summary statistical information about it. So this is really cool. This is a great way to just really quickly and easily get summary statistics. And one thing that you might note is that this looks a lot like a data frame, right? It's the same appearance as we actually had within when we initially imported our data. So one thing we might want to do is to be able to actually save this summary data into its own Excel or CSV file. If we're generating reports, if we're wanting to present summary statistics to somebody up the administrative chain, right? Whatever reason you might need to take this data, save it, and present it, we can do that. So since this is a data frame, I'm going to go ahead and assign this to a new variable. I'll call this. So I'm just going to edit the cell that I have here. So where I have df.describe, at the front of that, I'll put df underscore summary space equals space. And so now instead of df describe just returning us information and printing it to screen directly, we're going to save all of this information we got into a new variable. There are conventions in Python, just as with every programming language, about how to name your variables. Generally, we use what's called snake case, which is for most common variable names, which is putting underscores between words. So now that I have this within this variable, I could, in a new cell or just at the end of that cell, do df underscore summary and run that just to make sure, all right, we do have the information that we expect stored there. And if we want to write it to a CSV file, we could do df underscore summary period 2 to underscore. And if you stop there for a second, you should be getting autocomplete information. And Pandas allows you to write any number of different data formats. So this is tabular data, could go into a bunch of different things. I could write to a CSV file, so comma separated value. That's my preferred thing. You could write it to JSON, JavaScript object notation, which is a popular data format. You could write it in to an Excel file. So with that XSLX file type, I'm gonna go and make this one a CSV. So I have df underscore summary period 2 underscore CSV, my parentheses, right? I'm calling the function. I need to pass it some parameters. The only necessary parameter is a file name. So I'm going to tell it, or I'm going to put quotation marks. So this is going to be a string for a file name. I'll call this fy20 underscore summary underscore table.csv. And so once we run that cell, if over on the left-hand side of your screen, you see a little folder, if you click that, if you already had that open, hit that little refresh button in the middle icon. But otherwise, you should now see this fy20 summary table.csv. So we just took some data, we imported it, we cleaned it, we got rid of some of the stuff around it, we calculated summary statistics, and then we actually wrote those summary statistics to a new file. I think that's pretty cool. This is a really standard workflow for me to import some Excel or CSV file, mess around with it in a bunch of different ways, generate some sort of meaningful information out of it, and then write that to a new file. Let's try a few more things though. I know that we're at 2:48. We are going to try to be respectful of time and then write at 3, although I'll hang around for all and answer questions afterwards for anybody who's interested. But we're going to try to do at least a couple more things before we close up here. So we've done this initial analysis, or we've done some just like this scripted piece. Maybe we want to start asking some other types of questions. So one thing we might want to do is looking at some of these quantitative or numeric columns, we might be interested in things like the general distribution of data for any of these categories. Let's say we're really interested in ebooks, right? Do a lot of libraries have the same number of ebooks, or is it, do some libraries have a lot? Would we have a normal distribution, a spread there? That would be really weird, but maybe it's the case. Maybe this is something we're interested in. So let's see about how we could work with that. So we're going to start by writing our data variable here, which is df, where our data is. I'm interested specifically in ebooks. This is one of those column names that has the space in front of it. So we have the space, E, capital B, books. You could have used the auto completion there. And one nice thing that Pandas gives you is built-in plotting. In Python, there's a lot of different plotting libraries. Some of them are really great. Some are not as great. They can give you static plots. They can give you interactive visualizations for the web. There's amazing things that you can do with visualization in Python. Also amazing things you can do with sonification if you want to turn your data into sound. And a good colleague of mine at NC State Libraries, Walt Gurley, teaches a workshop on data sonification sometimes. It's really, really cool. We're going to stick with visualization, though, and things that Pandas gives us sort of out of box. So we're going to have this df square brackets, and we're going to selecting this ebooks column. We're going to do period. So again, we're going to call some functions on this. We'll do plot, and then another period, hist, H-I-S-T, for histogram, and then the parentheses. So we have df, we select our column ebooks.plot.hist, and we'll run that. And this is really interesting. So we get back a graph that we can see sort of in place. We can see that the majority of the libraries that we have in this data set have around that sort of 100,000. So this is maybe like 70,000 to a little over 200,000 ebooks. But there's some library way over here on the right side that has much, much closer to 800,000 ebooks. Right. So this has a histogram. It's giving us how many, it's binning our data. So how many libraries have values within this range? That's what we're seeing on this graph. So what if we're really interested to figure out which of these libraries actually has this astonishing 800,000 ebooks? Well, we can use Pandas to check that out. So in this case, we're going to call df again. We'll put our square brackets because we want to subset our data. What we've really been doing every time we're putting a column name there is we're subsetting our data. We're saying, just give me back just this column. So we'll start in the same way. But in this case, we're going to write df again because we want to subset based off of a conditional. We want to say, give us back any of the rows that satisfy some condition that we put into our code. So the condition I want is where df ebooks is greater than 700,000. So we have df square brackets, and then inside of that is our conditional, so something that evaluates to true or false. And then there we're selecting, again, the df ebook column. We use our greater than symbol, which is the sort of angle bracket, 700,000. And so we can see that this is actually High Point Public Library. And if you scrolled all the way over, you could see they have 816,392 ebooks. I don't know if anybody here is from High Point Public Library. And you have an explanation for why you have so many ebooks. I found this very interesting. I'd love to know the reasons why. But it's really an outlier in the data. Is this actually an error in the state library data? Is this really true? Why is it that High Point Public Library has so many ebooks? Great question. And it's the type of question that we can sort of figure out expose when we're doing this type of exploratory data analysis, which I think is fun. So, all right, I know that we've got about 7 minutes left. So we're going to try to do just 2 more lines. So somebody mentioned early in chat that they love pivot tables, or at least have to use pivot tables, enjoy pivot tables. So we're going to do something that's very, very similar to pivot tables here right at the end. What we would do in Python, though, in Pandas is called a group by statement. So not exactly the same thing as a pivot table, but very close. And anything that you could do with pivot tables, you can do with group by statements. So what we're going to do, we're going to start with this df dot group by. So what I should say is we want to group all of the observations by way of a particular column, and then aggregate the information in the other columns by way of some statistical measure, whether that's a sum, whether that's a mean. That's our general approach. What we're going to ask is maybe we want to see the average of all the values for all those different cataloged items for all the different counts of how many of any resource a library has. And we want to aggregate those by way of those library type categories, whether it's municipal, regional, etc. So we want to group by the library type. So we have df period group by, that's our function that we're calling. And what that takes is a list of the column names that we want to group by. You could group by multiple columns. We're going to group by just library type. And then we need to call another function after that group by, which says, how do we want to aggregate the data in all those other columns together? In this case, I want to use a mean function. So we call .mean. I want to take the average of all the values. So what we can see here now, again, just a short line of code, we've grouped together the rows by way of the library type, county, municipal, regional, and then all of those rows that satisfy county, all the ones that where it's municipal, we've scrunched all the data together by way of the mean function. And we can see on average that, for instance, municipal libraries have far fewer cataloged adult books on average than county and regional. That makes sense based on the type of libraries that they are. But this is a really handy way. You could think about all the different variations that you could do. You could, if you had different data in this data set, you could group by multiple different columns. You could only look at a couple of these. If you have factor data, things like county, municipal, regional, there are ways to sort of turn that into pivot tables. And in fact, Pandas does have a pivot table function. So if you really love and are used to the way that pivot tables work in Excel or in Google Sheets, you can really directly replicate that within Pandas just with .pivot table, go through the correct, get the parameters right in it, and it works. So one last line of code, and then we're gonna go ahead and wrap up. And that's just because we might look at this and want to turn it into some sort of visualization. And again, if we're thinking about doing exploratory data analysis, which is really a lot of what we've done here, we wanted to sort of get something quick using the library that we've already got and see what we learn from it. So I'm going to actually take this line of code, the df group by library type mean. I'm just going to copy that entire thing, put that down into the next cell, and then add on to it. So what I know I get back from this is a data frame here. So at the end of it, I want to call .plot, .bar. I'm just going to do a bar plot and plot these together. The one thing I'm going to pass in here, so we do have to, after bar, put the parentheses. We're going to call that bar function on the data. I'm going to set the size of this just to make sure that the legend doesn't interfere. So I'll put fig size. So what's the size of the figure equal to, and then give it 20 and 10. It's just going to work in this particular case. I experimented with it till it did. And it's a little bit small on screen, but what you can see is we have the different library types across the bottom. So county, municipal, regional, and we can look and do a direct comparison. Again, this is the average data, but we're able to take a look at that. So there's a question about if you want to look at only certain columns in the group by table, would you put column names in brackets in the mean? It is a parameter that you pass in. I would need to jump into the Pandas documentation to figure that one out. I just don't have it right off the top of my head. I teach this stuff a bunch and I still look at the documentation all the time. I've been writing Python for like 8 years or so now. This is one thing I'll tell you, no matter how long you write code, even if you've been writing the same language for 30 years, you're still going to look at the documentation very regularly, and that's completely okay. So if you're just starting off, go for the documentation all the time. That's just how you write code. I think it's great. So, all right. So that's the end of the workshop. That's all the sort of code that we wanted to write together. I hope that this has been really useful. You might be asking, why are we bothering to do this in Python? You could just do all of this in Excel, right? You could do pivot tables, you can do summary statistics, you could save new files. So why do this in Python? I think it's fun. That's in some ways the biggest thing I would want you to maybe take away from writing a little bit of code. A small amount of Python can get you a really long way. I think it can be a lot of fun to do. I think it feels like you're experimenting. I love writing a line of code, getting the immediate feedback of results that are right. So I think that's a huge amount of fun and enjoyable. I think there are other compelling reasons though, work-wise. It could be that you are wanting to do a number of different computing tasks. Python can help automate those things for you. Could be that you're running the same reports again and again. Again, Python is able to help automate that. I think that if you start to get used to writing Python code, since it is a general purpose language and you can do so much with it, then if you learn it in one domain and start to build up that skill set, then you can apply it in other domains. Here we're working with tabular data, but if you get used to Python syntax, just get used to writing code, you could easily go over and process XML files. You could process MARC records. You could start working with doing text analysis on comments that people have left on your library website or on emails or on any number of different types of data. You could extend and build a web application if you wanted to. So by gaining a little bit of knowledge, a little bit of expertise in something that's really flexible, it lets you really apply then lots of domains in ways that could make your work or your life or whatever you're doing a little bit more fun, a bit more interesting, and hopefully more efficient, more productive. So I think that there are some really great reasons. And the only way to really learn is to just keep doing it again and again so that it starts to really sink in and feel good. So at the end of this document over in the field version and on that GitHub page, I do have some resources that you can look at for learning Python beyond this. I think all those things are fantastic. So do feel free to go and jump into those. I know that we are right at 3, so I'm going to go ahead and wrap up. I don't know if Devin has anything else that she needs or that they need to add. Thank you all so much for hanging in here and writing code along with me. I enjoyed this. I think it's a lot of fun. So it's really a pleasure to get to talk with you. I'll Devin wrap up, and then I'll hang around on the Zoom call for a few minutes for anyone who has questions and wants to ask, and I can try to answer some of the other questions in there. So thanks so much, everybody.
Thank you so much, Scott. I don't really have anything to add. I'm glad that people have responded so well to this session. Just keep an eye out for that follow-up email today with the link to the recording, the resource link, and a follow-up survey. If you loved this session, please let us know. If you have follow-up feedback or some suggestions for future topics to cover, please let us know in that feedback survey. I think we have a couple of questions that are lying around at the end of this session. So I do want to field those to you to make sure if those folks are around. Rihanna is asking, is it possible to save the bar graphs in the same way that you saved the summary table?
Yes, it absolutely is. It can get a little bit trickier because part of what's happening is Pandas is calling another library called matplotlib. So we would need to go back and directly import that matplotlib library, create the figure, put the data on the figure, and then use that to save it. There are examples of that in the Pandas documentation. And if I was Googling this, the other thing that you do a lot when you write code is you Google tons of things. I would be Googling save pandas figure, or just Google that, or save pandas figure to file. But you can save it to a PNG file, to a JPEG, to different types to be able to work with it. Some of the different Python data visualization libraries make it easier to save files, and then they can directly work on Pandas data frames as well. The one I really like is called Seaborn, Seaborn. It's a really great library that works with Pandas and gives you really nice high quality graphics and can really let you set the parameters so you could put them into either a PowerPoint presentation, into one of the big posters like you might give at a conference, to put it into a paper, an article, or a report in a PDF, really high quality. So, looks like the next question there, if we were exploring non-tabular data like XML, MARC XML, are there Python libraries I find most useful? So for MARC, one thing I've learned at NC State, we do have a Python interest group among librarians, and some librarians are from our acquisitions and discovery department. And they've been working with MARC records with Python. And there's a library called PyMarc, PyMarc, which lets you work directly with MARC records. At a broader level, one of the libraries that I used to work with XML, especially when I'm doing text analysis, is called Beautiful Soup. Beautiful Soup is a fantastic library for parsing and navigating XML. There's another one just called eTree. So there's a number of different libraries. If you know you're working with Mark, I would definitely go with PyMark. But if you have sort of generic XML or XML that has other schemas, then you might look at Beautiful Soup as a first step. Any other questions that folks have? Whether about Python, what you can do with it, things that help you be successful in learning, any different questions that you might have. I think now we have a smaller group, and if you did want to unmute, I think you could. I think that has the recording ended, Devin?
I can stop the recording now.